Everyone, and welcome to this explainer. Let's just dive right in, shall we? Today we are focusing on exactly what it says on the tin. NCP-MCI 7.5, 12.3 NearSync specifics. If you're an infrastructure admin gearing up for your Nutanix certification, you probably already know your way around AOS 7.5 and HV 11.0. But NearSync? NearSync has some very specific kind of quirky underlying behaviors that test writers just love to throw at you. We're not going to rush this. We're going to cover this subtopic thoroughly at a steady pace, really digging into the actual mechanics and the deeper architecture. So grab a coffee, get comfortable, and get ready to take some detailed mental notes.
All right, here is our game plan for today. First, we'll cover why NearSync specifics actually matter. Second, we'll do a walkthrough of LWS and the transition process. Third, we're going to expose some common exam traps. And finally, we'll wrap up with the key facts you absolutely have to memorize.
Starting with Section 1, why NearSync specifics matter, which is really about looking beyond just faster asynced. Okay, we first need to establish why NearSync isn't just a traditional asynchronous schedule that happens to run faster. It's actually a fundamentally different mechanism, and it requires a very specific understanding from an administrative standpoint. The real game changer here is lightweight snapshots, or LWS. You see, in a standard asynchronous schedule, you take a snapshot, and then you have to move all those changed data blocks to the remote site. And you know how it is. Moving massive data blocks takes time, it eats up intense amounts of bandwidth, and it can even cause VM stun. Not great. But NearSync, it introduces LWS to operate strictly at the metadata level. Instead of lugging around heavy data blocks, it continuously generates these snapshots to replicate just the incoming metadata from your workloads. Because it's only metadata, it's incredibly fast and, well, lightweight. And to manage all of this, the system automatically allocates a dedicated LWS store right on your SSD tier just to hold these specific recovery points.
Now, this metadata-centric architecture is exactly what allows us to hit a recovery point objective, or RPO, of just 1 to 15 minutes between different availability zones, or AZs. As a quick refresher, RPO defines your maximum acceptable data loss in terms of time. Hitting a 1-minute RPO is obviously a massive deal for mission-critical apps. But if you think about the physics of networking for a second, trying to achieve a 1-minute RPO without this metadata-level tracking would be practically impossible over a standard wide-area network. It absolutely relies on a constant, highly optimized stream of metadata flowing between those availability zones.
Moving right along to Section 2, let's do a walkthrough of LWS and the transition process to really understand the mechanics. So how does this actually translate into concrete administrative tasks? Well, this comparison perfectly illustrates the mechanical difference. Think about traditional snapshots for a second. They move heavy data at strictly scheduled intervals, maybe every 60 minutes. It's super reliable, sure, but it is fundamentally a batch process. You're scooping up and moving heavy, discrete buckets of data. On the flip side, lightweight snapshots continuously stream those tiny metadata changes. It's a flowing, constant stream of information, rather than those heavy buckets dropping every hour. This shift in mindset, from batch processing to continuous flow, is exactly what the exam will expect you to grasp when you're evaluating disaster recovery capabilities.
Now let's look at our first concrete example. Let's deliberately walk through exactly what the system does when you first configure a NearSync schedule in Prism Element. Step 1, you apply the schedule in your dashboard. Easy enough. But Step 2 is where the magic, and honestly the bottleneck, happens. The system does not just instantly give you a 1-minute RPO. No way. Instead, it has to take and replicate an initial hourly snapshot for seeding. This means full, heavy data replication. Depending on your pipe and the size of your data, this seeding process can take quite a while. Only after that full baseline data is successfully seeded across the wire to the secondary site do we actually reach Step 3, which is where the transition to your minute schedule finishes and that continuous LWS stream finally kicks off.
Let's pause here because we really need to understand the underlying why behind this seeding requirement, because this gets tested heavily. The system physically cannot calculate minute-level metadata deltas until it has a full baseline snapshot seeded to the recovery site. It's kind of like trying to collaboratively edit a complex document with a coworker who lives on the other side of the world. That other person absolutely needs the full original file downloaded onto their laptop before they can start receiving your real-time line-by-line edits, right? If they don't have the base document, your rapid-fire edits mean literally nothing to them. It's the same here. The cluster strictly relies on that standard hourly snapshot to establish the baseline.
Okay, let's look at a second concrete example, a network degradation event. What actually happens when your bandwidth randomly drops and the cluster just can't keep up with that aggressive 1 to 15 minute RPO? Well, the system is incredibly smart. it automatically transitions out of NearSync. When this happens, it immediately throws an alert in your dashboard, letting you know the stream is broken, and it falls back to a standard hourly schedule. But here's the cool part. It doesn't just give up. It continuously retries in the background. Once your bandwidth stabilizes, the network clears up, and the delta is successfully seated again, it automatically transitions back into NearSync, and it generates a brand new alert so you know your highly aggressive RPO is totally protected once again.
And that brings us to a massive concept for the exam, which I like to call the hourly safety net. Every single NearSync schedule you create actually includes a hidden, internally generated 1-hour schedule. This is 100% automated. As an admin, you don't go in and manually configure this fallback. Prism Element just handles it under the hood. The cluster intentionally retains the last full hourly snapshot so it can roll up those NearSync snapshots. Why? Because it guarantees that you always have a stable, reliable fallback RPO if that highly sensitive continuous LWS stream breaks due to something like network jitter. You are literally never left without a recent, solid recovery point.
Section 3. Common exam traps and edge cases, also known as the pitfalls. All right, let's dive into the tricky scenarios that test writers love to use to trip you up. Imagine you're sitting for the exam, feeling good, and this exact scenario pops up on your screen. You've just clicked Save, applying a 1-minute RPO NearSync schedule to a supercritical database VM. The question asks, what happens in the Prism Central web console immediately after? Think back to what we just discussed about that transition phase.
The trap here is assuming the process is instantaneous. It's not. The schedule absolutely remains hourly. If you go look in the web console immediately after clicking Save, you are only going to see hourly recovery points until that heavy initial seeding phase completes and the transition is fully finished. So, whatever you do, do not select the multiple choice answer that says 1-minute snapshots begin immediately. They absolutely do not.
You also need to keep a few other strict limitations in your back pocket, because they show up all the time as distractors in those multiple choice questions. First off, NearSync does not support application-consistent snapshots. It strictly takes crash-consistent snapshots. Second, while a protection domain can have any number of asynchronous schedules, it can only have one NearSync schedule, and you are hard-capped at a maximum of 2 remote sites across all schedules in that domain. And third, here's a big architectural must-know. If you're running ESXi, the Nutanix data distribution architecture dictates that all Nutanix cluster nodes must map to a single vSphere cluster. If you split them into multiple vSphere clusters, your disaster recovery operations are going to fail, period.
Which brings us to Section 4, Key Facts to Memorize, the cheat sheet. Let's lock in the non-negotiable facts you need to pass this specific section of the exam. You absolutely must memorize this capacity limit. When the system automatically provisions the LWS store on your SSD tier, the absolute maximum allocation for each node is strictly 360 gigabytes. Or if you happen to be running a hybrid system, it's 7% of the SSD capacity on that specific node. So mentally highlight that number right now, 360 gigabytes.
Honestly, if you only take away 3 things from this entire explainer today, it needs to be these 3 absolute pillars of NearSync. Number 1, lightweight snapshots use metadata only. Number 2, when you apply a schedule, it strictly stays hourly until that initial seeding process completes. And number 3, the cluster always automatically retains the last full hourly snapshot as a built-in fallback to protect you.
And I want to leave you with one final edge case to watch out for. You might actually see a tricky question asking if an RPO lower than 1 minute is even possible. The answer is technically yes, but only under a very specific condition. NearSync can achieve an RPO as low as 20 seconds, but exclusively for vStore protection domains running on an ESXi cluster. These 20-second snapshots are kept locally first, and then they're rolled up before replicating over to the remote site. Just make sure you remember that word, exclusively.
So, knowing how strictly NearSync relies on its hourly safety net and seeing how it elegantly transitions in and out of minute-level RPOs based entirely on your network's health, how are you going to evaluate your own cluster's resilience the next time you log in? Understanding these exact mechanics doesn't just help you memorize trivia to pass the NCP-MCI 7.5 exam, it actually makes you a vastly better, more confident infrastructure architect out there in the real world. Keep studying, keep reviewing these concepts, and you are going to absolutely crush Objective 12.3. Thanks so much for learning with me today.